Hello and welcome to this Blue Marble Geographics webinar on Geographic Calculator. Today's topic is going to be Geographic Calculator 2016, specifically what's new in the Service Pack 2. My name is Sam Knight. I'm the Director of Product Management here at Blue Marble Geographics.
And my name is Jeff Hatzel. I'm an Application Specialist here.
Today we're going to be broadcasting a re-recording of our session from February introducing Service Pack 2. We had some technical difficulties during the recording of that session, and so this is a rebroadcast. What we're going to be going through is the introduction to the basics of the application. We're going to have Jeff is going to walk us through a basic overview. Then we're going to take a look at specifically the new features that were introduced in Service Pack 2. We'll also conclude in a normal live broadcast recording. We would have live questions from the audience. In this case, we're going to revisit some of those questions from our original session. As always, if you have any questions while watching this video, please feel free to visit us on the web at bluemarblegeo.com or send any technical questions to our support team at geohelp@bluemarblegeo.com. So to get started, Jeff's going to walk us through a brief overview of the main features of the application for those of you who are completely new to Geographic Calculator.
Thanks, Sam. And so when we first open Geographic Calculator, what we see is the start page. One thing the start page features is our job guide, and this job guide lists all of our jobs. Each job, if you were to click through, shows a little bit of a summary about that job, along with the supported format types for that job as well. On the right side of the start page, we have our news panel. That is web updated that shows relevant information for Geographic Calculator. The panel on the left-hand side of the application is our project manager, and that allows us to see all of the jobs available within the application. To get started, we'll take a look at an interactive conversion job. And this is the most basic job in the application. We input one point location and then have the ability to choose our source and our target coordinate systems. When choosing a coordinate system, we have the option to do so by geographic area. And so in this case, we'll do that. And we have the ability now to pick a point on the map and see all the available coordinate systems for that location. In this case, we see a short list of the 2 systems available in North America, or we can look at all the systems available, most of which are global or regional, relevant to that region. If we hadn't chose to search by geographic area, we can then look to our folders on the left and we'll see that all of our systems are available. And under the All tab here, we'll see that there are about 5,000 systems available. For example, if we wanted to navigate to a geodetic system, in this case NAD27, which is relevant to where we're working, we can do so through our folder tree on the left. If we were to right-click on the system, we have the ability to view info. That allows us first to see the definition of the system, so it covers things like area of use, point style, and the datum. The Identification tab shows some remarks available from the Epsg, and then below that we can see our identifiers, so all the codes used by different issuers who may have this system in their library. If we didn't want to navigate through the folder structure, we could also use the Find taskbar on the bottom here to search for a specific system. And now we'll see it brings us back to the same available systems as we saw before, and we could also open them in the folder where they are stored. Now that we've chosen an input coordinate system, we would follow the same steps that we just did, but this time to choose an output coordinate system that we want our point to be converted to. Once we have an input and output system chosen, it's then time to choose our transformation. And when we do this, the transformation selection window is loaded based on area of use. And so we see transformations that apply to that area of use. Sam, could you maybe tell us a little bit about what other factors come into play when we're looking at transformations here?
Sure. So the transformations each have various levels of accuracy depending on the data that they were derived on, the extents of the area of use that they're for, and the various methods of transformation. So the main ingredient here for making the best selection is going to be this accuracy statement for each of these transformations. So here we have 4 transformations, and we'll see that one of them is a single transformation, and the second, third, and fourth there are actually combinations of multiple transformations. So in this case, several that go from NAD27 to WGS84, and then WGS84 to NAD83. For each of those in the accuracy column, for the single transformations, we'll see this first one here, the NADCON transformation has an accuracy listed of 15 centimeters. Really what that is the certainty of the output data location. So transformation itself will always build in a little bit of inaccuracy in the data. It's simply endemic to performing a transformation. And in the case of a single transformation, this one that is the national transformation here in the US is accurate to within about 15 centimeters. And these double two-step transformations here, we have one that is made of 2 transformations. One is 4 meters accurate, the other is 5 meters accurate. These others at the bottom here are 1 meter accurate and 5 meters accurate together. Those are not necessarily additive, but give you an idea of the overall accuracy and quality of the transformation that is going to be done. Now those different areas that they apply to, these really just help us have a quick sanity check on where these transformations spread across to. So in the case of the first one here, this is a transformation that is valid throughout the entire US. If we take a look at this one here that's localized to Maine, this transformation suits only this much smaller geographic region. That itself doesn't particularly say anything about the accuracy of the transformation. It just gives you an idea of where that accuracy applies on the map for this given transformation. So here, our sort of obvious choice is the first one, NAD27 to NAD83, using this NADCON method, accurate to about 15 centimeters. We can right-click on that, open up its parameters, and find all of the defining information, whether they're mathematical parameters or lookup tables in this case, and things like the identification for how to cross-reference this transformation into other places. So for this shift, we're going to go ahead and simply double-click to grab onto that first shift and come back to our main interface here.
And so now that we have our transformation all set up, we do have options if we wanted to either record a log file or a printable sheet so that we can have an output of this transformation if we chose. But now we can go ahead and calculate that, and we'll see our output coordinate here in our NAD83 UTM zone 19 north. And if we go to File and then Print, we can print a report about this conversion, or we have the ability to go to Options and record interactive conversion as well. And what we like to say is that if you can set up a conversion in this interactive conversion job, then you can do it in more or less any job within Geographic Calculator. The next job we'll look at is the point database conversion job. And so unlike the interactive conversion where we're only entering one point, the point database conversion job is based off of tabular data, and so we have our data in columns. We have the ability here to support XLS, XLSX, and a variety of ASCII formats, which you can also customize with our text scheme. You'll notice on the bottom that we have the same CRS setup as we saw in the interactive conversion job, so that should look familiar. The only real difference here is now we need to choose input and output columns, which represent our X and Y, or latitude, longitude locations. So Sam, can you tell us if there's any limit to rows which we can load here?
No, so that's the most common question folks have about this interface, is how much data can it handle through here. For those folks that are working with ASCII formats of data, so those are text files, those freely structured files can be incredibly long, millions upon millions of rows. But the way we handle data here in the point database job essentially lets us process unlimited amounts of data through simply partially loading that file. So you'll notice there's a little checkbox at the very top of the interface about only loading the first X number of records. There is also a little safety trip. If you load data that has more than 100,000 records, it will offer you the chance to partially load that data. And when we go into that partially loaded mode, it lets you preview just enough of that data to set everything up and take a look at a test conversion, and then it can process an unlimited number of rows following that, and it simply writes it directly out to disk. So it's a very lightweight process on the machine, and you're only limited essentially by the storage space you have available to write that data out to. There are a couple of just simply file format practical limitations, particularly on XLS and XLSX. Those Microsoft Excel formats, the formats themselves are row limited, so XLS files are limited to 65,000 rows, and XLSX goes out to 1,000,000 rows, respectively. But each of those are essentially the only limitations, and it typically is the ASCII formats where we're talking about the very, very large data through here. While we're here, this is also a good place for us to point out one of the newer features on this interface. At version 2016, released last January, we added in a new control here for visualizing the point database table, and a new piece of that that's come along is this little divider up here at the very upper left corner of the database control. This little thing, it looks like a little series of dots in there. As you hover your cursor over that, you'll see the standard cursor for being able to move something around, like resizing a window or relocating something. If we click and drag that, you'll see that we can drop that anywhere into the grid. And what that little divider actually does is it allows us to freeze the panes. So as we scroll away from that, if we scroll over to the right, you'll see it locks in place all of the columns that are before that, and it allows us to then scroll in the remainder of those things. So the column freezing can be stuck anywhere in that grid that we like. It's one of those new little features that's come along with this extra grid control. We're finding it pretty handy, and we think you probably will too.
In addition to the traditional point database conversion job we've just looked at, we have a variety of other point database-based jobs for other specialty conversions and applications. Sam, would you like to tell us a little bit about the Seismic job?
Sure, okay. So the Seismic survey conversion job is really a streamlined and specialized version of the point database job. I say it's streamlined because it does away with some of the things like the column settings. You'll notice those are missing from the input and output. And this is because we have very rigidly structured data formats in things used for seismic surveying. In particular, this example file here is called a SegP1 file. It's a very specialized ASCII-based format. The columns for those are always located in the particular place in the file. So we have latitudes and longitudes and eastings and northings for projected coordinates. Conversion is exactly the same, so the same CRS controls we have for input and output, but a streamlined job that helps us both very quickly set up a conversion, but also gives us some options when we're loading that data in to do things like clean the data up through the process of stepping through a load wizard that helps us highlight the different areas of that data file. Now these are rather complex. They tend to have a lot of variations found around the industry. And some of these extra tools really just help us clean these files up and more easily achieve the conversions found inside those.
Next, we'll take a look at the vector data conversion job. And this job has a very simple interface, and what it allows us to do is convert about 20 common vector formats, so shape files, tab files, the CAD formats, KML, and a variety of others. You'll notice that the CRS setup is the same as we have been seeing throughout all of our other jobs. And so the vector job allows us two other extra functions for both layer splitting and cropping layers. And this just allows us to specialize our conversions on certain areas of our loaded layers if need be. The raster job is set up very similarly to the vector job. In this case, however, we have support for a variety of raster formats. Unique to the raster job is the Geo Referencing tool. This allows us to georeference any images that we load into the application. We also have the ability to set some image-related settings. These settings pertain to resolution, background color, compression, and other features for image exports. So for all the jobs we've covered so far, we have the ability to process them via a batch process. And to do that, we can right-click on the job and go to Batch Add. And this is as simple as setting up one transformation and then adding all of your data files to it.
Okay, thanks Jeff for that overview. For the rest of the session, we're going to be focused specifically on the new features in Service Pack 2 of Geographic Calculator 2016. And these are focused on a few different areas. We have some updates that we're going to take a look at in the area calculation job. We have some new geodetic parameters that are kind of interesting conversation, some new coordinate systems that are going to unlock some possibilities. And we've got a new tool in the data source menu for importing and exporting objects from a Petrel CTL coordinate system database for a little deeper integration for users of Petrel software. We're also going to take a quick look at the GeoCalc Registry. That is a new beta website that we are releasing. That is essentially a geodetic parameter repository where you'll be able to browse and view the latest updates to the geodetic database as they are added from different resources, things like the Epsg database or things that we assemble from other locations. So to get started with this, let's take a look at the updates to the area calculation job. On the area calculation job here, for those of you who are new to the job, what this allows you to do is to define the geometry of a polygon in any coordinate system in the database, so taking into account its projection. This is a three-dimensional area calculation, so it does actually calculate the surface area on the ellipse of the datum that we're working with. Now, the area calculation job has been in the calculator for several major releases, and we've done some refinement to it at this particular release. So particularly, we did not previously have the ability to do things like multi-select given rows in a polygon when we're editing some of those geometries. We can now multi-select those rows, and the process for that is just like multi-selecting multiple files in Windows. You simply hold down the Control key, or you can also Shift select to get the first and last and everything in between. But that new ability to multi-select rows in there allows us to either, say, delete multiple rows at once, or it actually allows us to update some of those path to next attributes in here. For those of you, again, not familiar with this job, this allows us to do things like connect the dots between these vertices describing a polygon, connect those dots following different paths, either things like a geodesic line, sort of as the crow flies, what we think of as a straight line between two points, following the path of a parallel if we have two points on the same latitude, or if we want to follow things like a grid path in projected space, which is going to be distinct in most cases from a geodesic path. If we want to say update the say the first 4 of those rows to, instead of following a geodesic path, we want to say follow a grid path, we can now multi-select those and update those en masse. This is a big streamlining thing for those of you working with complex geometries and doing that high precision area calculation function. The other thing that we've done to this is much more subtle. A lot of folks actually don't even notice that we've made some of these updates, and that is simply that it takes fewer clicks to modify anything on this interface. We had a little bit of redundancy on a few things, like if we were going to simply click to update a single path to next field or a single checkbox field, we would have to click that to select the row and then click it to drop down the menu and so on. And so we've streamlined the code under the hood of this interface, and now we can simply do those one-touch updates to get right into the setting we want to update, such as unticking a box and things like that. So those should help us streamline the process of setting up the area calc job for those of you that are working in this space. I mentioned that there are some updates to the geodetic data source. So I'm just going to go down under our data source menu and pull up our coordinate system definitions. There are a number of new coordinate system definitions found throughout the database. I'm going to focus on a couple of very special ones that are found in the world category. And these are actually the various G codes of WGS84. As well, there are a number of ITRF systems that have been added. And for those of you who work with these day in, day out, you may notice that these are things that we've already had. And the reason I'm pointing these out is that they have now actually been recognized by the EPSG. And so you'll notice there are now EPSG codes associated with all of the various realizations of the WGS84 system at its various G codes. For those of you not familiar with those various systems, WGS84 has undergone several realizations over the years since the early 80s when it became a standard. The G codes that we're talking about there, in this case G730 in parentheses after WGS84, the G stands for GPS week, and that is basically the number of weeks since GPS was turned on officially live. That's a date in January of 1980. So the second realization we have there, 730 weeks from the initial realization of WGS84 was given its own realization designator. At 873 weeks from the GPS 0 day, it was realized, and so on throughout the years several more times. These have never been recognized by the EPSG database before, and that has actually made dealing with them a little bit difficult. We've had those in the database here of the calculator for the last many releases because we do have some time-dependent transformations that have not been recognized by the EPSG yet. But now, through access to a EPSG code, that is actually going to simplify the use of these systems when we start talking about files like GeoTIFFs and LiDAR files, where those EPSG codes are actually used as the identifying information for the internal referencing in some of those file formats. So it seems like a very small thing, but that's actually going to be a fairly exciting update for those of us working with very modern reference frame data in those sort of cutting edge formats like LiDAR and such. It will make data sharing a little bit easier and a little bit more unambiguous about which particular realizations of WGS84 happen to be getting used in there. We don't often get into the updates found new coordinate systems in the database, but those are actually particularly notable, even though they are a rather subtle update. As well, in the database, I'll just quickly mention a couple of other updates. There is a new time-based transformation for those of you working in Canada. That will be found under the coordinate transformation definitions. This is going to be a collection of datum shifts localized into the Canadian folder. This is going to be a set of time-based transformations that use a grid file and basically a time offset from those. It's a modification of the NTV2 type system. So it allows Canadian transformations to be done in a temporal sense. As well, there's going to be a new vertical reference for those of you working with some of the lower low water marks. There are several tidal references known as mean lower low, mean low, etc. There's all these variations that relate to the tides. And some of you have been asking for one called mean lower low water height rather than depth. It simply is which direction is going up versus down in those references. So there's a new mean lower low water height reference as a vertical datum option in there as well. Number of other new systems that have come along as we've updated to the EPSG version 9.0 as sort of the base for many of these definitions, and as always, all the additional things that are not yet in the EPSG database found in the geodata.xml at the core of the application. Now, the other main new feature that we've added to the Geographic Calculator at Service Pack 2 is an export function to export objects from the geodetic parameter database into a Petrel CTL database. So the CTL process is a little bit more involved than simply grabbing onto a single coordinate system or a single transformation and exporting that out to something like a well-known text file. This does actually require a slightly larger dialog, and it's a little bit more similar to exporting parameters out into a larger file like our own Blue Marble XML format for when you're specifically moving coordinate systems between installations of the Geographic Calculator that don't sit on a shared database. A Petrel CTL file can contain a very long list of coordinate systems and their transformations. There are specifically 3 things that can be found in a CTL file. That is a coordinate system, a coordinate transformation to go between 2 systems, and then what's called an early bound coordinate system. And that is a pairing of a coordinate system and a set of transformations for it to WGS84 specifically. So what we're going to do here in this dialog is we're going to build a list of coordinate systems and transformations. We've also got the option to do what we call promoting a coordinate system to be an early bound coordinate system where it carries its transformation right along with it. Now at the very top of the dialog here you'll see there is a location of imported CTL file and there's a load button. This really is intended to be a maintenance tool. So if you are working with a CTL file already over in Petrel and you want to bring that in here to either add things to it, modify things that are inside it, and so on, we can start by loading that up right in here and getting to the modification step. If you're starting from scratch like I am, what we're going to do is build a list of coordinate systems and transformations to export out. So to do that, what we're going to do is click the little plus button there near the top right. And this is going to open a coordinate system and transformation picker. So this is going to operate much like we do when we export out to the Blue Marble XSP format for sharing multiple systems and transformations and other parameters. There's just a few things we can pick in here. We can pick coordinate systems and we can pick some transformations for them. So as an example here, let's just go ahead and I'm going to grab on to some UTM zones that are somewhat near me here. I'll just grab on to say 18, 19, and 20. I'll click OK. We'll see those add into the list. Now, if I wanted to go back and select some more transformations, more coordinate systems, maybe I'd want to go down under projected, and if I'm making a list near myself, maybe I'd go back and grab onto some of the state plane zones here around Maine. So I'll just grab onto a few of those main definitions. Now for a transformation, I've got a few things here on WGS84. I've got a few on NAD83. I'm going to get one more set of coordinate systems, and that's going to be something based on NAD27, something with a more significant difference. So I'm going to go down under the UTM category here, and I'm going to grab onto UTM Zone 19 on NAD27. So now I have a short list of coordinate systems here, and again, you can add in however many systems you want from your main list. You might also be starting off with a list if we had loaded in a pre-existing CTL file that you already have to modify. Now, these are just coordinate systems. I can go back in and grab onto transformations just like any other set of parameters. So if I want to get some particular transformations that are going to get me from NAD83 to WGS84, for example. If I want to simply search some out, maybe I just want to search out some of those NAD27 transformations and so on. We can find those transformations, select them, view their parameters and such, just to make sure we're grabbing the things we intend to, and we add those to the list just in the same list as we have our coordinate systems in. So I just grabbed onto the NADCON transformation that's used throughout the US for survey grade transformations. Now I have a transformation and I have a coordinate system. If I want to do what's called early bind a transformation to one of these coordinate systems, so let's take for example our NAD27 UTM zone here, I can right click on that and you'll see an option to promote to early bound. And so what that's going to do is open a coordinate system selector, and this is going to allow me to grab onto a one specific transformation that's going to be linked up with that coordinate system. And that item, the coordinate system, will swap out in the list here. And we'll see we now have a coordinate system and a transformation linked together. So what this does is when we get over into Petrel and you're actually going to use these things, if you select this particular coordinate system from your database, you don't have to then select a transformation. The transformation is already attached to it as that early bound system. The opposite of that is the mode we use here normally in the Geographic Calculator, and that's called a late bound system. And that is where our coordinate systems don't have a transformation already attached to them as a part of their definition. So that's something that can be done over in Petrel. It's something that is done in a few other applications where the coordinate system comes with a default transformation already assigned to it. So that is the concatenated transformation you see here in the list. So those are the three object types that can be exported out into this CTL format. You'll see coordinate systems, datum transformations, and concatenated transformations, which is the pairing again of the system and the transformation to WGS84. Now there are a few other pieces of this interface, and they're mostly for reference, and they depend on the particular versions of your Petrel installation and so on. There is a little engine version tag that's used over in Petrel. You can set that to the version of the engine that you are using, version of the Esri projection engine that is that Petrel is using. You can set that tag appropriately to match the version of that engine that you need your CTL file to be read in by. And as well, there is what's called an authority tag inside the CTL file. If you don't have an existing authority, frequently the authority tag might be your own proprietary company name or something like that. If there is not one there that you're automatically going to fill in, there is a default simply of CTL that we'll put in there as a placeholder. Again, folks will regularly put in their own company name and so on. The final step, once we've assembled our list, done any of the early binding of the transformations that we're going to be doing, is to actually go ahead and export that out. That's going to save that out to us on wherever we choose to put that. I will simply go ahead and save that CTL file out with a basic name, and it confirms that it has been written out. Now, our success dialog pops right up there. If you are writing out many of these systems, it might take a couple seconds before that success dialog pops up. Most folks that we've encountered so far are working with fairly tidy lists, so it is usually a very practically instant process there for writing those to output. Now, again, if we are starting over, so I'm going to go ahead and close out of our CTL dialog there. If we come back later on and we wish to repeat that process, I can go right back into the export dialog. This is where we just were. And now I have the option to actually load that up. And I can grab onto our CTL file, open that back into the dialog, and you'll see all of the contents for that will display right back there. We can edit them, we can add things to it, we can delete things from it. This really is a management tool to maintain the items that are in that CTL database that you are going to be working with over in Petrel. So inputs, outputs, bringing them into Calculator from Petrel, taking them from Calculator, putting them back into Petrel. It's really a fully both directions here. That's the new CTL file export, and that's one of the main new features here in the Service Pack 2. The other new feature we'd like to introduce with this service pack is actually not inside the application at all. It's a new standalone website that we have here at Blue Marble Geographic. The domain is geocalconline.com, and what this website is a geodetic registry for geodetics parameters. Now, there are a few registries out there in the world, most famously the Epsg Web Registry itself. This web registry is hosted by Blue Marble Geographics. This is an initial beta release of this service, and what this allows us to do is handle all of the coordinate systems, ellipsoids, datums, all of the geodetics parameters that are found inside Geographic Calculator, which contains pretty much everything in the Epsg database and a few other things on top of that. So it allows us to extend the support of some of those standard databases like the Epsg Web Registry, but it also allows us to wrap some of our own tools around that same information in an effort to make things a little bit easier to navigate, find the latest things that are in the Geographic Calculator's own database, and access all of that information easily. So the web registry itself is this web page. You can point your browser right to geocalconline.com. When you first land on the page, there'll be a simple login, and that is simply going to be the same as your Blue Marble Geographics web page login that you might use to access our user forums or download applications and such. Once logged in, you have access to the full database. And specifically the search tool that the database is built around. So down the left-hand side of the panel over here, we have our search bar. And by default, this is left as a very wide net search. So if we simply enter in something like WGS84, that will by default search in things like the names of systems and various parameters like datums, the remarks, so the comments and things like that are associated with a definition, typically from Epsg or whatever publishing authority the system came from, various identifiers that might be codes used in several databases to identify a particular geodetic parameter set. We can get narrower with each of those, breaking them down into the specific categories found for geodetic parameters. But let's take a look at this from the broad sense. So I'll execute that search, and we'll see that there are many different things that come back from that basic search of WGS84. So we have areas of use, we have ellipsoids, we have various types of coordinate systems there, geocentric, geodetic, projected, vertical, datums, various transformations and such. So let's say, for example, we know that we are looking specifically for a geodetic coordinate system that has WGS84 in its name. Over on the object types filter, we might simply tick off the geodetic coordinate systems. That would only return search results that are a geodetic coordinate system with WGS84 in it. So let's do that search, and we'll narrow that down a little bit more solidly. You'll see we have a number of systems that come back, and some of these don't all have WGS84 in the name, so there are several other systems. Remembering that we are searching in names, remarks, and identifiers, so some of those other systems may mention WGS84 in their own parameters. So if we wanted to narrow that down a little further, we could just do a name search, and then we start breaking those down into the very short lists that we have here. So we can use very powerful tools, much like an online shopping experience, to narrow down categories of things we're looking for. Then once we zero in on the particular definitions that we have, we might just simply click on one to be taken to a page describing that particular parameter set. So we'll see things like the remarks. We can expand the view to see things like the identifiers. Again, identifiers being cross-reference codes that are used to identify a particular parameter set in different databases. So many folks are familiar with the Epsg codes that are found for a system. That is just simply one of the identifying codes for the systems in our database here. So that we've reached out into all of these other databases to find the lookups in those alternate places as well. Things like the Epsg history, which lets us get into the various revisions and updates of a parameter set, down into all of the nitty-gritty, things like point styles, areas of use information, all in a fairly compact view. So all of the parameters that are in the current Geographic Calculator application are found in the GeoCalc Registry. This allows us to see what is updated from the time. If you have an older version of Geographic Calculator, you want to see what those latest parameters are. It allows us an easy eye into the latest and greatest of all of those geodetic parameters. You'll see a couple special links on each parameter set. You'll see a URL and a GML and a WKT link. The URL, if we click that one, what that does, for those of you familiar with online forum terminology, the URL is essentially like what is often called a permalink on a forum. So this gives you an individual web address for a particular set of parameters. This is able to be copied. You just do a simple text copy on that. You can stick that in an email. You can instant message it to somebody. However you want to get that to them, that particular string of the URL, they can then load that up in their own browser and come exactly back to this same parameter set without having to do their own search to find it. That will open in a new window. The GML and WKT links in there, those are similar. And what those will do is open up a new tab in your browser and actually give you either the GML, Geographic Markup Language, or it will give you the WKT, well-known text string to describe the parameters in that particular geodetic definition. So this is the GML. Those of you familiar with browsing XML and things like that, you'll see some sort of familiar style tags in there. This is all readable. It is standard GML. This is ready to be digested by an application that can read GML of a definition. Likewise for the WKT, you'll see a particular text string in there giving you all of the full parameters of that definition. So this is a cloud-hosted registry service that we're starting to offer here at Blue Marble. We are working on additional functions to this constantly, things like streamlining this to be friendly to mobile web browser interfaces, things like that. Right now it's a little more optimized for a desktop experience. Throughout the spring we'll be optimizing this for a mobile display to get all of that what is sometimes rather dense information about a geodetic parameter set into a smaller screen space, fleshing out some additional search tools and some of the reporting capabilities, things like that. This registry sits right on top of the online data source that is already exposed in the Geographic Calculator. When you go under the data source menu, the new option that showed up this year about downloading online parameters, this now reaches into this very same database, and the web form version of this simply gives us a very nice front end to be able to explore that without needing to do so through the Geographic Calculator, but additionally giving us a little extra power in executing some of those searches. To narrow down and hone right in on the particular geodetic parameter sets that we're looking for. So we're rather excited about this. If you're starting to play with the GeoCalc Registry, we'd love to hear from you. Anything you'd like to see additionally in it, the type of work you're doing, what brings you to look up some of those parameters and things like that. This is a beta release. We're going to be continuing to work on this on an ongoing basis throughout the year and offering this as a steady new service to be digested both by Calculator as well as some of our OEM partner applications that are sitting on top of the GeoCalc engine for coordinate transformation. So this is an exciting new development for us, and we're looking forward to hearing back from some users that are working with it. So that is one of the other big new pieces here of the Service Pack 2 release of the Geographic Calculator. Okay, so for any additional questions you might have after watching the video, again, please feel free to reach out to us at geohelp@bluemarblegeo.com, and that'll connect you up to our tech support team here at Blue Marble. Thank you, Jeff, for joining me today.
Thank you, Sam.
And we'll see you next time.